All right, so we're going to talk a little bit about something called exponential growth and decay, which is extremely relevant in this day and age since we're dealing with it so much with COVID. We tend to see the same thing. All right, so we're going to start off by reading out our thing here. So we're going to suppose that Mustafa is building an addition to your home, right? Wherever you live right now, you're adding a little bit on. So Mustafa is working on that, so he needs to hire a contractor to build it, right? So actually this should be, this is a previous student that I had, Kai, but I was replacing with Mustafa. So everything is, this is Mustafa. Mustafa's slightly better looking twin, evil twin, quotes him a price of $150,000 to build an addition and 25 days of work. Now, Mr. Shantz, desperate for work, undercuts Mustafa's slightly better looking evil twin. And I'll do the job in 24 days work and work the first day for just a penny. All right? So the next day, I want to double my money. So the way my rate is, we could either pay, or Mustafa could either pay for his slightly better looking evil twin to do it, $150,000 to build the addition. Or he could pay me a penny for the first day, but every single day, whatever he paid me the previous day, doubles. What do you think is the better deal? Any guesses? And I'm going to do it in 24 days. I'll do it a day faster, but it's not about speed here. It's about who's going to be the better deal. Will it be me or will it be Mustafa's evil twin? Slightly better looking evil twin. More handsome. What do you think, Mustafa? Your evil twin or me? Who's the better deal?
No, my evil twin.
Not your evil twin?
He's evil.
He is evil, but he's got a pretty good price there. You're going to have to pay him $150,000. So that's what Mustafa's evil twin. And you're only going to start out by paying me a penny. But the next day you'll pay me 2 pennies. And the third day you'll pay me 4 pennies.
Okay, no, I'd rather I'd rather the total 150. Yeah.
The 150? You think I'm going to be more expensive than your evil twin?
No, just take it
How many
right away.
days?
Wait, every day for how long though?
For 24 days.
Just a penny?
No, not every day. The first day you pay me a penny, but the next day you pay me double that. And whatever. So every single day you pay me double whatever you paid me the previous
Oh,
day.
do the math.
Power 24, right?
What's that?
It's like 1 to the power of 24, but like,
Well, we'll see. We're going to add it up.
I'd rather get the money on the
because you're doubling it every day.
Yeah, I'm doubling my price every day.
No, I'll still choose the 24 days. Yeah.
Okay.
Because it won't add up to $150,000.
Yeah, it's that's expensive. It's a lot of money, right? $150,000 for your addition. Maxime, what do you think? Who do you think's cheaper, me or Mustafa's evil twin?
Wait, it starts with 1 penny or 2?
1.
But then the next day would be 2, and then the next day would be
Yeah.
4.
So we go like this. My first day,
Next day was
right? So on the first day, I get 1 penny. On the second day, I get double that, 2 pennies. On the third day, 4 cents. So I've made a grand total of 7 cents so far. What a deal for Mustafa if he hires me. 7 cents in 3 days.
I didn't get that sheet.
Did I not give it to you? Here, sorry. Here you go, Chris. All right, but on the 4th day, 8 cents. Wow. I can almost buy a piece of bubble gum off somebody. And then on my 5th day, 16 cents. Look out. I'm going to be rich soon. On my 6th day, that's 32 cents.
Oh, yeah.
On my 7th day,
The 150, you got me tripping. I got into the second box and I'm going to pay $16,000.
Yeah.
You're going to keep timing that by 2, it's going to go to 200.
Yeah.
see, after a week, you barely even paid me, like, I can't even do it for $1. I can't even get a cup of coffee for how much work I did.
Yeah, see, it go 132,000. That's
But after 10 days, Mustafa is now paying me $5.12 on my 10th day. And my 11th day, I got 10, 24. And then I got 20, 48. And I'm getting 40, 96, 81, 92. And then I get 163.84. $327.68.
Yeah, I'm done with my 10.
Well, that's the one cause they have AC.
$1,310.72. Okay, now I'm starting to get a little more expensive.
I went to the end.
Add it all up. Making some good money in my last couple days there. And my last day, I make $83,886.08. Now, did you add it all up?
Why would we add it up?
Because that's how much do I make total? Because you want to figure out my total cost. How much do I cost in total? You need to add up how much you paid me throughout the whole thing.
Wait, if you like worked a day, you'd get a cent the next day, would you get 3 cents or 2 cents? Because is it in addition
Double
to the day
whatever
before?
I get it all added up, right? How much did I make total? I made a penny the first day. On the second day, I made 2 pennies. On the third day, I made 4 pennies. How much money did I make in total? Add up all mine.
You have to add them all up.
Yeah.
That means that you would have made what you made that day plus the previous day.
Yeah, so add up all how much money I made out of all those days, right? Because Mustafa's evil, slightly better looking twin was only going to charge $150,000, or a lot, $150,000, which sounds like a chunk, right? But who's a better deal? Me or Mustafa's evil, slightly better looking twin? I think it adds up to, and I could be wrong, but I think it's $167,772.16. So it's kind of close. Now, you might be sitting there thinking, how did he figure that out so fast? And the answer is, I used the formula that I taught you guys before, which was to find the amount is equal to my it's this letter P times growth rate to the power of time. So in this case here, I did it by going like this. Amount equals, now this is my starting amount. Which was 0.01, right? And my growth rate was double, so I wrote 2. So it's multiplied by 2 to the power of 24 days. So what it looks like is 0.01 times 2 to the power of 24. And that's how I got my answer of 167,772. Now, you could add it all up, which some of you guys might have done, and you'd find that you get the same amount. But there's got to be a faster way, right? In math, there's always a faster way. We're not going to sit around adding it all up. All right, so this is an example of exponential growth. And a lot of things work this way, whether it's bacteria cases, it could be COVID cases, it could be money that you're making. Money grows like bacteria sometimes because there's a growth rate. If we have a percentage increase, it could grow really fast. And some of us talked about like GameStop or something like that, and you could talk about money, how you can make lots of money, and how you could also lose lots of money just as fast, if not faster. All right? So in that particular situation, that's exponential growth. And again, I'll go into the details of that equation a little bit later, but I want to look at the other example. So let's look at bacteria. So a colony of bacteria, right? And this happens to you every single day. So if you take a shower in the morning, right, and you clean yourself off, and you get most of the bacteria off of you, well, there's all kinds of living things that live on you. And bacteria grow really fast, right? Don't even Google what's living in your eyebrows right now. It's the grossest thing ever. Not even joking. Right now, you're covered in bacteria and little mites and all kinds of different things. And they grow fast, right? And the reality is most of them actually do something helpful for your body or for yourself, right? There's bacteria in your gut that helps you break down food. So I'm not sure how many people like to eat yogurt. Yogurt's just basically bacteria, right? It's good bacteria. It gets in your gut and helps you digest things. So yogurt's a good thing to eat. I'm not sure what's another good thing to eat. That's
Fiber? Well, I don't know if that's
bacteria. So, and it starts out with 100. Right? So our colony of bacteria is going to start out with 100, and it doubles every single day. So on day number 2, how much bacteria do we have? Yes. 200. And then day number 2, we have 400. Day 3, we have 800. And, 1,600. All right. So if we said, what would the population of bacterial colony be after 1 week? What about 3 weeks? Well, we'd have to figure that out. And we can chart that on a graph. So we're going to put it on the graph here. And we're going to go like this. So it starts out at 100. We're going to have our population on this side. And here we'll do like our number of days. Right? So let's go like this. And let's go like, yeah, let's do it this way. I'll make each one 250. Now they're also changing the math curriculum, probably too late for you guys, but they're going to be changing it and making it more orientated towards financial literacy, meaning understanding about how money works. And that's super important because you guys, I think I've talked to you about this before, but when you don't understand that there's so many ways that you could be making money, I think I told you this before, that it's once you have money, it's so much easier to make money, right?
Yeah, because you can just like invest it.
Yeah, if you invested a large chunk of money, it returns much faster, right? It's like a snowball. If you start out with a very small amount, like it grows, but only very slightly, right? But the longer you leave it in, it's just like my rate, right? It's like my rate with the house price. It starts snowballing. It goes really fast and it starts gaining lots of momentum. So once you get super rich, it's gaining super fast. And it's super easy to stay rich. And in fact, if you guys had, let's say, $10 million, I can guarantee you that you wouldn't have to work a day for the rest of your life. Because you'd have the money, and your money would just keep making money, and you could just sit there on your butt and make way more money sitting in your butt than doing any kind of job anyway. Yeah. So that's the thing. So once someone has money, realistically, they don't have to do anything. They can live off the interest and still be making money and still have a giant pile of money to live off of, as long as they lived within their means of how much money they're making each year, right? So as long as you didn't go around like renting giant yachts or buying super yachts and buying McLarens and stuff like that, then you'd probably be fine if you just lived your regular life. But you wouldn't have to work, right? Have fun.
But we can't spend it on...
You could still spend it. I'd say if you had $10 million invested, I would make a budget and be like, I can't spend more than $100,000 a year, which is hard to spend anyway.
Yeah.
I don't even make $100,000 a year, right? So like we're talking about like a lifestyle that's already pretty crazy. $100,000 a year is a pretty wicked lifestyle if you're actually making that much money. So if you had $10 million, if you just didn't touch that $10 million and you invested it, you'd be getting the interest every single year, and it would snowball and make more money and more money and more money, and you wouldn't have to do anything. And eventually, when you died, you could hand that $10 million over to someone else in your family, and then they can sit on their butts and do nothing for the next, and that's how rich people live. That's what's going on, right? Meanwhile, the rest of us peasants here, have to work our butts off to make things work, right? So that's the reality of the situation. Most people are not that rich, but those people who have the luxury of doing that can do nothing if they wanted to. All right? Okay, so let's graph this. I'll put this on the graph. I'll put these points on here. So we start off at 100. So at 0, at 100, it's around like there. After one day, we said it was 200, which is there. 2 days, we said it was 400. Which is around here. And then we get to 800, around there. And the fourth day, we're at 1600, which is around there. Now, if we were to double that, on the next day, obviously, we'd get to 3,200, 6,400, and then 12,800, which you can tell is going to be like way off the charts. So right off the bat, we should be able to see that our graph is looking like pretty stupid. It's like this. That's what an exponential curve looks like. Yes.
That kind of makes sense when you think about bacteria, because when Corona started, it was like very little and not a lot, and then within like, it felt like a week, it just like jumped super high.
Yeah, and that's all it takes, right? It just builds and builds and builds, which is why, like yesterday was how many cases of COVID? It was like 60 something or whatever, right? But if you go back to when there was like 20, right? After the lowest point we probably got to after the last lockdown we had, I think it got down to like 12 or 1 or something like that, which is great. But if it keeps building and building and building, and if it, like yesterday was 60, the day before that was like 50, I think, or 40 something. But on the weekend, it was like, it actually hit like 84 or 82 or something like that. So what we do is when it's fluctuating that much, and we're trying to look at like COVID cases, for example, we actually just take the average over 3 days, right? And we take like, it's called a moving average. Same thing in finance. When we're looking at stocks and things like that, we take the moving average because the price of a stock, individual stock, might go pretty crazy over 1 or 2 days. But so we have to look over at a longer time scan. So or we might look over a 7-day moving average. All right. So the way things are going currently with COVID, it's not good. Like we should be hitting triple digits probably by the end of the, my guess would be by the end of that week off that we're taking, the April break off. And if we're hitting triple digits, it's going to be locked down for sure. Like there's just no option. We have to. Or people are going to start dying. And not just old people, like young people are going to die more. Apparently the new COVID variants, by the way, actually affect you guys much more than the previous one does. So the fun days of just not worrying about it and it's just the old people is starting to change. And that's what happens with viruses. When the longer they're out there, they eventually mutate, right? It takes them time and they can mutate and they become more dangerous. So again, bacteria isn't always bad. There's good bacteria too. And it's growing in you and on you. And you kind of have a symbiotic relationship. Yes?
Isn't COVID-19 a mutation of SARS? Or like a mutation of some?
It's the similar, the virus itself is similar, which is why it's called, it's like SARS-CoV, whatever.
Yeah.
It's the same base type virus,
Okay.
but it is slightly different.
Isn't it more contagious?
It is more
SARS
contagious.
Really was, it was bad, but it was not.
It was bad, but it wasn't as contagious as this, right? And there's actually a really interesting movie that has something like this on there. It's called Outbreak. I'm not sure if you've heard of the movie Outbreak before. You've seen that movie? And it's like it has the monkey that brings it over. And at first it's a contact or spit saliva disease that's transmitted that way. And eventually it mutates into this airborne thing. And they make it more like a branch off of like the Ebola virus, which is actually extremely dangerous. That one actually has a high kill ratio. Most diseases don't kill off everybody. They actually usually only kill off like a smaller percentage. Like you would think it's a small percentage. Like COVID's percent kill rate is like 1% or something like that. It's not a lot.
Still a lot of people. But
It's a lot of people when we're talking about from a population of billions. 1% is like tens of millions, right? So it's a lot, which is why we're concerned about it. Like the flu has a kill rate that's like 0.05% or something. It's much lower than that. But then Ebola's kill rate is like 20-something percent or 30 or 40%. It actually kills a lot of people.
only like a few countries. Like,
Generally,
I've never seen an Ebola.
but if it could come here,
Yeah.
if someone had it, and it could come, and that's why they're so scared of it ever coming here. Usually, it's Ebola does best in hot tropical environments, which is why we tend to find it in Africa most often.
And isn't it also in like the Dominican areas?
It has never showed up there, but they had the Zika virus,
Yeah.
which is a different one. That's the one that's picked up by the mosquitoes, and if you get stung by a mosquito,
That's
that one's a terrible one too because it deforms babies. So babies are like get born with brain damage. Would you want that? No, that's terrible too, right? So they're worried about the Zika virus. There's so many different viruses we're worried about, and because our world that we live in is so global, people can just get on a plane and go somewhere. It's scary. It would take over the planet very fast. And which is why they were so much concerned about when COVID first came out, some people were just like, whatever, new virus on the TV, no big deal. But if we don't do something right away, if we do not take actions right away, this is what happens.
which they kind of did.
They didn't. Exactly. They did not. Right? Trump did not. Our government did not. Nobody understood what we were dealing with. Yes?
Trump didn't even want to be in lockdown.
He did not. But like lockdown is something that there's only two questions, really. It's when do we want to go in lockdown? Do we want to go in lockdown early on? And hopefully if we do it early on,
Or after, or you went bad.
or wait till everything turns to crap and then we go in lockdown, and it's going to be for longer, right? We're going to go in lockdown kind of no matter what, almost. Yes.
I feel like one of the best things they could have possibly have done is just everywhere went on lockdown for like a month. And like that was difficult to do because like obviously stuff has to be running like water and electricity and stuff like that. But like if only one place goes on lockdown, like you said, the world's so global that like when you get out of lockdown, it'll just come back.
Which is exactly the problem that's going on right now. So Hamilton's in lockdown, we're not. So people can just get up and be like, all right, well, I want to go shopping. I live in Hamilton. Where am I going to go? Well, I'm going to go to Mississauga. I'm going to go to Grimsby. I'm going to go to St. Catharines. I'm going to
That's why Toronto is closed. It's literally everyone in Toronto would just come down here literally to get groceries.
Yeah.
Like, what?
Which is why that doesn't work. And they'll figure that out eventually, that doesn't work. And I think the doctors know that it doesn't work. It's just the politicians that don't want to do it. And so there's a lot to do. It's hard to do, right? It's a hard choice. You have to tell business owners that they can't be open. They're going to lose lots of money. You're going to lose jobs. Nobody wants businesses to lose money and lose jobs. The government makes less money when that happens.
And no politician wants to be the one with the bad economy.
Yeah, no one wants to say no. No one wants to be the one. But then you look at other countries like Australia and New Zealand, and they actually did the opposite of what we did. They went to exactly what you said, and they're having live concerts outside. And they have no cases of COVID at all.
They're also really like
They're isolated.
no
Yes.
one really wants to come on the street.
Yes. Well, mostly because everything in Australia is designed to kill you. So between the crocodiles, snakes, and spiders and whatever else is there. Okay, so that is exponential growth. We'll do one last example here, and we're going to look at exponential decay. So sometimes things decay as opposed to grow. All right? So here is an example. So in this case here, we have a ball is bounced from 40 feet, and each bounce it loses half its height. Right? So every time we have a ball that's bouncing, so it starts off here, it bounces, and then it goes up, and it just is half its height. And that's pretty much how a ball works. It probably actually loses more than half its height, but it really depends. But we could use this model to predict how many bounces or how high it's going to be on a bounce if we're looking at bounces. So it's going to get smaller. So it starts off at 40 feet, and then each bounce, it gets smaller by half. So one bounce, it gets back up to 20 feet. On the second bounce, it's at 10 feet, 5 feet, 2.5. Are we talking about feet? Yeah, we are. So we're going to do 2 feet, 2 feet and 6 inches, because we can't do decimals technically. All right. So can we make an equation from that data? And the answer is we can. So the height is equal to our starting point times decay rate, all to the power of, here it's going to be number of bounces. All right. So we're going to graph these points here. So same idea. I'll do my chart. I'll move it over here for this time. And then we have our height, and it is in feet. And we're going to start from 40, 10, 20, 30. Let's go like this. Let's make this 40. This is 30, 20, 10, 5. All right. So we start at 40. And then after one bounce, it's here. And 2 bounces, there. 3 bounces, 4 bounces, 5, 6. I'm kind of estimating 5 and 6 there. And if we were to draw our curve through it, it kind of looks like that. It's the same idea. So according to this equation, will the ball ever stop bouncing? Will the ball ever stop bouncing? Will it ever hit 0 according to this chart that I'm doing here? If it's just half the number before it? It technically will not.
No, so it'll be a decimal. Always. Because you have half of 1 divided by. It'll be a decimal always because you already have a decimal.
Exactly. So it goes into decimals, and the decimal goes smaller and smaller, but it's just reduced by half. But it would technically never actually reach 0, which is why this doesn't quite explain our world perfectly, right? So while this does explain the rate of the bounces or the height of the bounces, it doesn't actually mimic real life perfectly. There are some errors to our model, all right? And that would be the fact that we have other things like that loses energy each time, right? Right? It's just like if I took a pendulum, if I hung something up for here and I swung it back and forth or on a swing, it will swing back and forth, but eventually it'll stop. Why? Why not just swing? Shouldn't it keep its energy? Shouldn't it maintain its energy each time?
Because there's gravity.
Yeah, so gravity's causing it to swing and it should keep going because of gravity.
Keep a momentum forever though.
But it loses energy from friction, from the thing swinging on that. There's different things. There's going to be air resistance as well. There's different things that suck the energy away. Otherwise, a pendulum would go forever. Now, if we had it in a vacuum, so there was no air resistance, and we had we could make it so there's 0 friction whatsoever on our pendulum, the pendulum would swing forever. It would just keep going back and forth. All right? But we don't live in that world. And same with the basketball type thing. So the basketball bouncing, it's going to stop bouncing at some point. It won't follow that perfectly. So our mathematical model doesn't explain it perfectly. All right, we got 5 more minutes to our break. So I'm going to just go over this one practice example. All right? So I had a student that's named Austin, but let's go with Ethan, because Ethan has not started any of my equations, I think, yet. So suppose Ethan starts a terrible rumor about Mr. Shantz that he doesn't actually write his own notes, but steals them from Mr. Tomeno when he's not looking. He tells 3 people this rumor after 1 hour. An hour later, those 3 people tell 3 people. This carries on with everyone who's just been told another person each hour. After 7 hours, how many people would be told this terrible, completely untrue rumor? Right? And we could draw it out if we wanted to. We could go like this. The rumor starts from Ethan right here. So Ethan's right there. Right? And then Ethan tells 3 people. Right? Ethan tells 3 people. That's hour number 1. And then those 3 people tell 3 people. Right? And if we wanted to draw it out, we could do it that way.
21 people are going to know.
21 people?
Yeah.
After 7 hours?
Yep.
Are you sure?
Yep.
I bet you this is like my 2 hours. I bet you I could do it already more than me that. It's going to be after 3 hours, it's probably 21 people. Yeah, because it's going to be 9, 9, 9. 3 times 9 is 27. So after 3 hours.
61.
I'll show you an example. This is why I put this up here. Not sure if you guys have watched this movie. Probably not, because you're not as old as I am. But
well, you know how these things start. One guy tells another guy something, and then he tells 2 friends, and they tell 2 friends, and they tell their friends, and so on, and so on, and so on. You know how these things go.
right? So I could draw it out, or what I want to do is if I figure out my amount is equal to my starting amount times my growth rate to exponent is like the number, it would be like number of hours. Right? So the amount of people that know, how many people knew at the beginning? Just Ethan did, right? Ethan was the first person. And then Ethan told how many people? 3. And they tell 3 people each time. So it's going to be to the power of 7. So the amount of people that know is 3 to the power of 7. 3 to the power of 7 is 2,187 people. After 7 hours, if every person told 3 more people, that's 2,187.
You're gonna get fired.
I know. Or Mr. Tomato's going to get mad that I steal all his stuff. Allegedly. Allegedly. I actually don't steal from him. I steal from a teacher at Eastdale. So, all right, break time. 12:55. We're going upstairs at 1 o'clock. So.